Hey there, welcome back. So today we are going to talk about the HUD or heads up display. So that's this area in this particular game. So why do we need it, or do we need it, and what do we use it for? Well, we can use it for several things, like for example keeping track of our score, our lives, the player's health, stuff like that, or you could display a map or keep track of power-ups, for example. So here I have an example for displaying a map. So you could show where you are in your game, and you can display something like the area that you're currently in. And having I have an example displaying other kinds of values: attack, defense, how much money you have, what kind of items you have, the player health, and so on. And in this case, the HUD would be placed on the right side, and in this case, you would have it maybe on the bottom of the screen or the top of the screen. So basically, what we use HUDs for is displaying important information like this. So in our game, this is of course the score and lives. So very simple. And of course, we need to have some way of updating the HUD. So now I'm going to collect this spinning coin over here. So when I collide with this coin now, notice this score area. We go up to 100. And what happens if I collide with this monster? Then you could see the lives went down by 1. So we need to have some way of updating the HUD in our code. Now, as you might have guessed, I made a library for that. So I have a HUD library here. So in my HUD library, I have subroutines like update player lives, for example. So when I lost a life and I collided with the monster, I need to run this subroutine together with some other things, of course. But this is important for updating the HUD, updating the player lives. But I also have a subroutine for updating the score. So when I collide with the spinning coin, then I need to update the score. So I have a few things like that: reset score, remove HUD. I have a few subroutines here. So the point is that we have to, like with everything else, we have to have a way to control the HUD. And it's very tidy if you have it separated like this. So this inside the HUD library, those things only concern the HUD. But we had the subroutine down here called remove HUD. That's just going to hide the HUD, so that's just going to be a black area if for whatever reason I need that. But where is the HUD drawn in the first place? Well, this might not be completely intuitive, but I draw the HUD in my room library. So in my room library, I have, of course, this load room routine that we have seen before. Loading the room, loading the level. We've seen that before. But I also have a subroutine down here that's called load char map. Now load char map actually just means that I'm going to load a different kind of room. So in my load room routine now, that's based on tiles. So I'm drawing background graphics based on tiles, the 2x2 tiles that we have. So my HUD is not made that way. Maybe you remember back when we were drawing the HUD, we were just drawing it with normal characters. We weren't drawing the HUD with tiles. So I have a subroutine here to draw what I call a char map. So this can be used not only to draw the HUD, but also to draw other things that are made up with just characters like that. So let's take a quick look at the charpad now. So here we have my HUD in Charpad. So if you remember, we made two different Charpad files. The one file, one of the files we have our map in, the game itself, all our rooms and those things. Now in this case I have a separate file just for the HUD. And like we just talked about, here I'm not drawing with tiles, here I'm drawing with normal characters like this. So now I don't need, like I said before, I don't need to make a 2x2 tile just for this area, and a 2x2 tile for this, 2x2 tile for this, stuff like that. That would be a waste of tiles, because we only have 64 tiles in this game, and if I was going to use a tile for every one of these, that would use up a lot of my tiles. So I'm not going to be doing that. So instead I made a little char map here, a map of characters. So like we've seen before, I just draw this and I go to File, Import, Export, Binary, and instead of export flexi-gridded submaps like we did with our actual game, the map of our game, instead of doing that, I just say export map. That's going to export this character map. So character for character, basically the same concept as our tile-based map, but in this case, instead of tiles, we have actual characters. So screen codes, if you want. So that's how the HUD is set up like that. So that's why I need some kind of system to load and display the HUD. And while we're here in Charpad, let me just quickly show you something else. So in this case, I was a little lazy. So I could have made a fancy start screen just by using this method, drawing some fancy characters, stuff like that. But I was a little bit lazy, so I actually made a start screen made up of tiles here. As you can see here, now I'm in my normal, this is my normal game map, right? So here I just made tiles for these things. So I'm just exporting this whole thing and I'm treating this start screen as just a normal room. And here I have the game over screen, also tiles, as you can see here. And this is also just another room. So that's not ideal, of course, because here I'm using, like you see, I'm using tiles, and I'm also using up two of the rooms for just displaying start screen and game over. So you can, of course, do it that way, and as we have seen, we know that it works, but it's maybe not the best way to do it, because here you can see as I'm spending 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm using 16 tiles here just for my start screen and my game over screen. So like I said, I just wanted to show you that so you're aware of how I did that. But ideally I would have made some fancy start screen here in another Charpad file, because I do have a routine to draw character maps like this now. So I just wanted to show you this now. So the load char map subroutine, it works basically almost the same as my draw room routine, but here of course we are dealing with characters instead of tiles. And not just that, but I made it a little flexible so I can start drawing it on the screen at the X position I want and at the Y position I want. So I don't have to start drawing it from the top left corner like we do with our rooms. Our rooms start at top left corner. I start drawing tiles like that. Here I specify where I want to start, the X and Y position where I want to start drawing this character map, which of course is going to allow me to start drawing it on the right side of the screen. So I have a char map start X, and I specify those things here in my config file. starting position, and starting X position, starting Y position. I specify those in columns and rows, since we are talking about characters. And I have a few other values here as well, only concerning the HUD. So again, this config file is really nice because now I can just go in here and change values. And if I did everything right with my libraries, then I can just go in here and change something, and that's going to change something in the actual game. So we don't need to go through this in detail because, like I said, it's just the concept is the same thing. I'm loading I have two loops. One keeps track of what row we're at, and the loop inside that keeps track of what column we're at. So the concept is pretty much exactly the same. Just a loop inside a loop to draw this character map. But let's take a look at my HUD library now. So I have to admit that this is not the greatest code. I just threw it together as an example, and like always, I tried to make it easy to understand and easy to read. And it is what it is. But for my update player lives routine here, basically I'm just loading X with HUD player lives Y position. So I'm getting these values from my config file now. And here I have the starting position, the X and Y starting position, not just for the HUD, but this time it's for the player lives, because I want to have a little guy that's going to I want to use this character. I made a separate character for player lives, and I want him to start drawing lives here. So I need to have a starting position, X and Y starting position, where I want to draw those lives. And that's what I specify here in my config file, the X and Y starting position for my player lives. And ideally you would want to have that inside the HUD area, of course. So I just say take the HUD starting position +1 when we're dealing with the X value, and for the Y take the starting position Y +8. So I'm just saying starting position of this whole HUD, but now we're dealing with the player lives, so take the starting X position of the HUD and +1. So I'm going to move 1 character to the right, and I'm going to move 8 characters down from wherever the HUD started to draw. So that's gonna put my lives here. Even if I was to move the HUD around, this would still work out fine, because I'm saying that the player lives should be drawn at this position relative to the starting position of the HUD. So hopefully that makes sense. Here I say HUD max player lives, so 6 lives is the maximum, and that's just because I only had 6 spaces here to place lives like that, but I think 6 lives should be enough anyway. So I have stuff like that in here. So when I say load X with the HUD player lives Y position, that's actually what row we are starting at. So I'm loading X with that, and I do that thing we have seen before. From my row low and row high table, store those in the 0-page variables. And same thing with my Y. This time I'm loading the X position. So basically this concept is the same, but now I'm using these values, the starting X and Y position, from my config file. So that let's see, so that now when I'm setting up my update player lives routine here, I'm specifying the start position where we should start drawing characters, the player lives character. And I start by making a loop to clear player lives. So I want to because now we're just writing characters to the screen, right? So I just want to clear that line, those 6 characters, in case there was some leftover characters from before, or if I have a game over, or whatever. If something happens, I don't want there to be any lives characters there. I need all of I need all of these 6 characters to be black when I start this. I don't want there to, for example, be a character here. So when I start drawing lives, if I have 2 lives, start drawing there, and there was a leftover character here. I don't want that, so I just blank those out. Just draw a black character across like that. So that's what's happening here. Clear player lives loop. Just blank out that line. And you can see here, before this loop starts, I'm loading a with HUD blank char. That's here in my config file, that's screen code 32, which is a space. So 32, that's this black character here. So the normal space character. I'm drawing that to clear that line. So that's what I'm storing at this position. And I'm storing that HUD max player lives that many times. If you remember, HUD max player lives, that was 6. So basically I'm clearing that row. I'm doing that 6 times, 6 characters. All right. So then I say, I do this same thing again, because this first loop was just to clear that row, and now the second time I have a similar loop, but this time instead of drawing a black character, now I'm drawing HUD player lives graphic. And HUD player lives graphic, that's character 240. 240, that's this little guy here. So I'm drawing that to display player lives. And how many times should I do that? Well, I have to write that character as many times as the number of lives I actually have. So I have a variable called player lives that actually keeps track of how many lives I have in my game. So this could be 2, 3, whatever. And this loop is going to draw my player lives character that many times. So if I have 2 lives, then I'm going to draw this little character 2 times. If I have 3 lives, then to do 1, 2, 3, and the loop would stop. So it's going to draw those characters until I reach max player lives, the number of lives I currently have. So it's pretty simple, really. I'm just drawing a character based on my player lives variable. But I like to clear that row before I start drawing lives, so that I always have an up-to-date. So this is always going to be up to date, because I'm clearing the row before I start drawing the actual lives. Okay, I hope that made sense. So that's how the update player lives routine works. Now the update score routine. This is something I wouldn't say I'm super proud of this. This is not the best code I ever made or anything like that. But again, I tried to make it easy to read, easy to understand, and it sort of works. So let's just take a look at it. Update score. So now I need to update my score up here. Now, there are so many ways we could have done this. for my score, this is important. My score here is 1, 2, 3, 4, 5, 6 digits. So I could have a score of 99999. So how much is that? It's like what is it? A million, almost a million, something like that. So that's of course way out of what we can store in a byte. Now, we can't have that a number that big in our CPU. We can't store a number that big in the any memory address, anything like that. So what I did here, I split up my score into 6 bytes. So every one of these numbers is just a byte. So if I go to my player variables file, I have my variable player lives here. We've seen that. But here I have my 6 variables for the score. Now this is what I was talking about. We could have done this several ways. Basically what this is just a table, right? But now I've displayed it as 6 variables instead. Now the main reason I did that was because I wanted to show you that this variable is going to keep track of that digit in my score. This variable is going to keep track of this digit, and so on. So every one of these variables is going to keep track of their separate digit in my score. So then it's up to me to make sure that those are displayed in the correct order. So how do I do that in my update score routine? Well, first of all, when I run my update score routine, I do the same thing as my player lives. I have a starting position, X and Y starting position. So same thing like I did with my player lives. But here I have my update score loop, which I start with loading X by 0, with 0. So how does this work? Well, I take my score variable, the one with this digit, comma X. So now I'm actually treating this as a table. Now remember, variables and tables, those are just words that we use, but in reality the Commodore 64 doesn't know about tables or stuff like that. It just deals with memory addresses. And like I said, now I placed 6 variables one after the other. This is exactly the same as what a table would look like, because now we're in memory. So this is a memory address, this is the next memory address, this is the next memory address, and so on. So these are just 6 memory addresses, one after the other. That's exactly what it would look like if this was a table. So there's really not a difference in memory. But for us as programmers, it's nice to sort of think of it as I have a variable and I have a table. Maybe that's easier for us to think like that. But anyway, I have these variables, and here I'm treating it as a table. So I'm sorting load A, score with this first variable, comma X. What does that mean? Well, I just loaded X with 0 here now. So I'm loading score this, comma X. So that's just gonna be this, right? But then I say clear carry, add with carry 30. Now hexadecimal 30. Now why do I do that? Well, because hexadecimal 30, that's the screen code for the 0 character. So if you go here to a charpad and look at the 0 character, you can see down here that this 0 character is hexadecimal 30. So I'm saying load whatever is in this variable, add hexadecimal 30 to that. That's going to mean that if that variable is 0, and then it's going to be 0 plus hexadecimal 30. That's just going to be this number, this screen code. But if that variable is 1, I say take that variable plus hexadecimal 30, then that's going to be 31. So I'm going to get screen code for this 31. So, but if the variable was 2, if this variable was 2 and I add this 30, then I get 32, which is going to be this screen code. So basically, just by adding that hexadecimal 30, I just display these numbers based on the contents of this variable. So I hope that makes sense. And here I just store it at the screen RAM address that we specified up here. And then I increment y because this is the first, so this is this screen RAM address. When I increment y, that's because I want to update this next time, and so on. That's why I increment y here. I'm incrementing x because this is my loop that I started with 0, and I'm comparing it with score digits, which I said over here in my config file. I said that was 6. So I'm basically running this loop 6 times. Now I'm incrementing x here, and I'll go up here. Now when I get to this variable again, comma x, now x has gone from 0 to 1 because I incremented down here. So this is what I was talking about. I write the label, I write the variable name here, but in this case it's actually working a little bit like a table. Oh, it is working like a table. So now when I write load A with this comma x, but the x was 1, then we're going to be 0, 1. So now we're actually loading this value. When x gets to 2, then it will be 0, 1, 2, then we're going to be loading this value from this starting address. So hopefully that's not confusing. So we're actually loading 1 byte after the other here. That's what's going on. So loading that, adding this number to it because we want the correct screen code to display numbers. Storing that in memory address for these score digits. So that's what we're doing here. Yeah, just updating the score like that. So that's updating the score. I also have something for reset score. That's just going to reset the score values. All right, but what I was going to show you was how do we add a number to the score. Well, this is what I was talking about, that maybe my code is a little bit clunky, but whatever. This is just to show you one way that you could do it. I made a macro called add to score with 2 arguments, one called value, one called place. And here I wrote a comment that says the place is where in the score the number should be added. So where in here should they be added? What place are we adding a number? So where the place is where in the score the number should be added. This is how we place value. This is how the place values are set up. So you can see here as an example. Here is how the score looks in the game, and this is place here 0. So this is place 1, this is place 2, and so on. So you can see how that works. So here's an example: add to score 1, 3, and the comment says this will add 1 to the 3 place. in this case we are adding 100 to the score. So we are adding what value? 1. What place are we adding it? 3. So here we are adding 1 to this place. This is the place for the 100 value. Alright, so then this is a macro, right? So we go down here and I make sure that I save my X register to the stack. Then I say load X with place, this argument. Alright, then I say load A with the score comma X. So like I just did with when I was updating the score, I'm treating this like a table, because I can do that since this is the first value. So as long as there are values that come right after each other like that, then we can actually treat them like a table. Alright, so I load that, and then I say clear carry add with carry value. So whatever I put in here. So I load that, add that value, and store it back into this. Then I say load A with score, that same thing, comma X, compare it to 10. Is that number 10 now? Because we can go from 1, 2, 3, 4, 5, 6. But what if the value in here, this is just, as long as we go from 0 to 9, it's not an issue. But what happens when that number is 10? Because every one of these is a byte, right? So there's no automatic thing that's going to say, oh, from 9, well, that's just 1 here and a 0 there. There's no automatic thing that's going to do that for us. So we need to think about that ourselves. So what happens if the value in this goes from 9 to 10? I compare it to 10. Then I say branch if carry set. So branch if equal or greater than. If it's 10 or more, then I inc next score value. Alright, what's inc next score value? Well, if it hasn't reached 10, if just from 0 to 9, then that's not a problem. So we're adding 1 to 5, for example. And that's just 6. And we get down here compared to 10. No, it's not 10. No problem. We're done. Jump, update score. So we're going to update the score. But this 10 thing could create a problem for us. So if it's 10 or more, the value in here is 10 or more, then I say inc next score value. So what do I do first? I say load A with 0 and store 0 in that address. So now let's say we had 900 here, but this just went up to 10 now. So what I'm saying here is first load A with 0 and store it in that value. So now I'm just saying 0 out this. Alright. The next thing is I decrement X, and that so this is maybe a little confusing, but now I'm going to let's say that it was this now. Now this would be 0, 1, 2, 3. Now X would be 3 when we are at this value. If we look at this as a table, X 0, 1, 2, 3. So if I load A with this comma X, and X is 3, then I would get this number. So what I did now, I changed this from 9 to 0. Then I say decrement X and increase score comma X. So what I'm doing now is that I just changed this from 9 to 0. But decrement X that means that I go up here now, because x is 0, 1, 2, 3. I just set this to 0, my decrement x, so x goes from 3 to 2. That means we are up here now. And I said increment, increase the value in that address. That means that we just went from here, where x was 3, so we went from x3 to x2, which brings us here, and I increase that number. So hopefully that makes sense. So basically we did this, we set that number to 0, then we changed x so that we go one step up and we increase that number. So yeah, hopefully that makes sense. So that's how I treat that score. Add that value and update the score like that. Now I'm just treating the actual values, and then down here I update the score, and now I just use the subroutine that we were just looking at. Update score in my HUD library after doing this operation. So as you can see, doing math, some simple math like this, can be a little tricky sometimes when we want to use large numbers in assembly language because of this 8-bit limitation. We can only have numbers from 0 to 255, and not only that, but when we actually want to show those numbers, it's not so simple to write the value that you have in the accumulator, for example, like this. You know, I have 255 in the accumulator. I'm just going to store that to the screen memory. So I'm going to display what's in my accumulator right now. Well, we wouldn't get this. If you have 255 in your accumulator, and that's screen code 255, so that would be this one. If you have 255 in your accumulator and you store that to the memory address, whatever, and you store that, you would just get this character. So as you can see, we need to think a little bit about how we display numbers like that. And what I showed you here, this is one way of doing it. Adding numbers like that and displaying them on the screen. And when you do something like this, then you can have big numbers, as you see. You can have, this would be a pretty big number. You could of course have an even bigger number. So that's how I treat the score in this game. Okay, well, that's it for the HUD. Like I said, there are many interesting things you can do with the HUD. Here was just a few examples to show you how you could update lives, score, things like that. So, like with everything else, you probably need to do some experiments, try different things out, but once you get this code, you can see how I did it here and maybe change something to get it like you want it. Or make your own code, of course. That's the best thing. Alright, well, you know what? Next episode will be the last in the course. But like I said last time, I'm going to make 2 more bonus episodes. So, that's it for now, and I'll see you next time. Bye bye.